Okay, so today we're going to be talking a little bit about nonlinear simultaneous equations, which are very similar to the process that we've used for linear simultaneous equations, but we're just going to have a bit of a different process in terms of how many solutions we're going to be getting out. Okay, so with nonlinear simultaneous equations, generally what's going to happen is you're not going to be able to use the elimination method, no matter what you do. Okay, in this particular example that you can, but we'll just focus on using substitution. Okay, so we've talked about substitution and elimination, but generally with nonlinear you're going to be wanting to go down the path of substitution, alright, rather than elimination, again because we're going to be working with x squareds and y squareds and all those sorts of things which are just going to make it a little bit difficult. Okay, so first things first, if we look at y equals x and y equals x squared, well, let's label them like we always do. Okay, equation 1, y equals x, is just a straight line, and equation 2, y equals x squared, is a parabola. Okay, so if you look here, we'll notice that it intersects at two different points. Okay, here the first point is 0, 0, okay, and here the second point is at 1, 1. So what we're going to do is we're going to show algebraically the points of intersection on these two curves using the substitution method. Okay, so you'll see us duck into this. So let's get started. Right, now with the substitution method, right, because they're both equal to y, that means we can let them be equal to each other. Okay, so they both equal the same thing, they both equal y, which means we can both let them equal each other. So essentially what we can say is we can let equation 1 equal equation 2. And essentially what we're doing here is we're just substituting in the value of y for this. Basically we're saying if y is equal to x, well then that means we can replace this y with an x down here. Okay, so let's actually do that. And essentially what we've just done is now x is equal to x squared. And remember, the whole idea of simultaneous equations is to find the point of intersection. Okay, we can't really do anything with this at the moment. We can't factorize just yet. So what we need to do is we need to get everything being onto one side of the equal sign. So we're going to get everything equal to 0. So we're going to minus x from both sides. Okay, so if we minus x from both sides, we end up with x squared minus x is equal to 0. Now don't freak out, all I've done is I've just switched the x squared minus x being over on the left hand side and the 0, which would have been here, over to the right hand side. That's all I've done. Now if we look at this particular equation, you can see, I'll just move this over, you can see what we can do is we have a common factor of x. So we factorize it, bring out the common factor of x, we're left with x minus 1 is equal to 0. Now remember, I've talked about this in class, this is called the Null Factor Law. Okay, that means that if we have two numbers multiplied together that equal 0, that means either one or the other is equal to 0. So that means either x is equal to 0 or x minus 1 is equal to 0. Okay, so this is in the final form that we can use this for. However, we can work with this one a little bit more. Right, we can add 1 to both sides to get the x by itself. So we end up with x is equal to, they cancel, and 0 plus 1 is 1. So you notice already we have two solutions. Whereas when we were working with just linear simultaneous equations, we only ever had one. But the process is no different. All we have to do now is for each solution, the x solution that we have, we just need to substitute it into back into one of our original equations to find the y value. So if we start with equation 1, right? So let's just say we're going to sub x equals 0 into equation 1. That means wherever we see an x here in equation 1, we're going to replace it with a 0. So therefore, y is equal to 0 because the x is the only thing in it. So this is a pretty simplified example. Okay, so let me just come down a little bit so you can see what we're doing. Okay, now we have y is equal to 0. That means we have a coordinate pair. Okay, a point of intersection at x equals 0 and y equals 0. Okay, so as a coordinate pair, that is equal to 0, 0. That's our point of intersection. Okay, so P, O, I for point of intersection. Now we can do the same thing with x is equal to 1. So we're going to sub x is equal to 1 into equation 1, just like before, right? And once we do that, we replace the x with a 1, all right, wherever we see an x. So this is now equal to 1. So our coordinate pair is x is equal to 1 and y is equal to 1. So on the Cartesian plane, the point of intersection is at the coordinate 1, 1, which we established here, just like before. Okay? So that's all we're doing when we're talking about nonlinear simultaneous equations. We're just finding the point of intersection between both of them. So our answers are here, x equals 1, y equals 1, and x equals 0, y equals 0. There are our 2 points of intersection. So again, we're mainly working with parabolas in this part of the video, so why don't we do another example that's going to be a little bit harder so we can have a play around with some of the things that we have to work with, okay? Okay, so for our second example, we're going to go for another straight line here. Okay, we'll label it equation 1, and another parabola, okay? Right, now these are just slightly harder, and I'll show you why these two parabola and a straight line in just a moment, but you'll notice now that we've just gotten a little bit harder in terms of we've now got some numbers and a few extra x's to deal with. Okay, this is no matter, we can work through this just like normal. Alright, visually, this is essentially what we're representing here. Alright, so this here is our parabola, okay, and this here is our straight line. So this is our y equals x squared minus x minus 2, okay, and this here is our straight line, which is y equals x plus 6, okay. So we are essentially trying to find these points of intersection here, where the two lines cross. You can see that visually, okay, it happens at negative 2 and 4 and 10, okay, but now let's show that algebraically. And this is where nonlinear simultaneous equations can get a little bit tough because we need to draw on some of our other skills that we've learnt throughout the year, okay? So let's start getting into it. Again, you'll notice that they're both equal to y again, aren't they, right? So essentially all we have to do, okay, is we can let them equal each other. If they're both equal to the same thing, they are both equal to each other. Okay, so what I like to say is I say let, you can say 1 equal 2, alright, another way of writing this is x plus 6 is equal to x squared minus x minus 2. And we're just doing that because they're both equal to y. Okay, so you'll notice going along here, alright, that we have some things on the left-hand side and some things on the right-hand side. What I want you to try and do is I want you to end up with everything here being equal to 0. So you want to try and move this over to the other side. Now to do that, okay, we can subtract x plus 6 from this side, right, and subtract x plus 6 from this side. So this is like us saying minus x plus 6, right, and minus x plus 6, okay? Right, now I'm just doing this in one step. You can do it in multiple, like minus x first and then minus 6 after, right, and do it out in multiple steps. I'm just doing this in one step here. Okay, so this leaves us with 0 is equal to, right, x squared minus x minus 2 minus x plus 6. That's all we've done so far. Okay, now expanding this out, we end up with 0 is equal to x squared minus x minus 2 minus x, expanding the negative through the bracket, minus 6. We can collect like terms, okay, we end up with, I'm just going to write this on the left hand side, x squared minus x is minus 2x, minus 2 minus 6 is minus 8, is now all equal to 0. Now remember, this is a quadratic equation, and in particular it's a monic trinomial, okay, it's monic because the coefficient of the x squared is 1. So we can use product, sum and factor, okay, method to try and factorize this. With product, sum and factor method, we are looking for two numbers that multiply to give us 8, negative 8, and two numbers that add to give us minus 2. So our product, alright, our product is equal to minus 8, our sum is equal to minus 2, and our factors that do this, okay, the two factors that add to give us negative 2 and that multiply to give us negative 8, are minus 4 and positive 2. Minus 4 times 2 is negative 8, and minus 4 plus 2 gives you negative 2. Okay, so we're just going to split the middle term into these two factors here. So we end up with x squared minus 4x plus 2x minus 8 is equal to 0. Okay, now we've spoken about this a few times, alright, we're just using this to help ourselves out. Okay, so let's have a little bit of a look into this, right? Now we can group in pairs. If we look for the first pair, the common factor between these two are x outside of x minus 4, right? And the common factor for the second pair is 2. So plus 2 outside of x minus 4 is equal to 0. Now, you'll know you've made a mistake if you get to this step, and the x minus 4 is not the same on both the x and the 2, okay? So you should have the same thing in the brackets for both terms, okay? Now that's actually a common factor. X minus 4 is now our common factor. So we can factorise it out, okay? So we end up with x minus 4 and x plus 2 is equal to 0. Okay, so again, this is another application of our null factor law. So we'll just come down a little bit so you can see what we're doing. This indicates that either x minus 4 is equal to 0 or x plus 2 is equal to 0. Okay, so essentially we can add 4 to both sides to end up with x is equal to 4 and subtract 2 from both sides to end up with x is also equal to minus 2. Okay, so these are our 2x solutions that you can see here, right, for the points of intersection. Now, just like last video, we're going to sub these two values back into our original equation so we can obtain some y values. Okay, so just like last time, let's work with sub x equals 4 into... Now, I'm going to pick equation 1 and I'm going to tell you why. If we go back up here to equation 1, right, we only have to deal with an x plus 6. We don't have to deal with squaring and minusing and all of those other sorts of things. We just need to work with an x plus 6. And that is the simplest equation to sub it into. So wherever we see an x, we replace it with a 4. Okay? So for the first equation, we have therefore y is equal to 4 plus 6, okay, which is equal to 10. So therefore our point of intersection occurs at x is equal to 4 and y is equal to 10. Okay? 4, 10. So that is our solution for our first one. And then, repeating the same thing, subbing x equals minus 2 into the first equation. Alright, we end up with y is equal to minus 2 plus 6, which is just equal to 4. So our solution is x equals minus 2 and y is equal to 4. So our point of intersection occurs at minus 2, 4. Alright, now if you actually come back here and have a little bit of a look at our graph, okay, at 4, 10 and minus 2 and 4, minus 2 and 4 occurs here, okay, right, like we said, where the two lines cross, our two curves, and 4, 10 occurs up here, which is what we were talking about, okay? So that's the general idea with what we're doing with nonlinear equations when we're doing simultaneous equations with them. Notice that we had to rely on some of our quadratic equation skills, okay, to be able to do this, so we are bringing in tools from other areas to help us solve these. Okay? Alright, so I'll cover another example on an ellipse and a line in the next video, alright? Just to give you guys a bit of an understanding of how those types of equations can work. Very similar method, but we just use some different curves, some different representations to achieve what we need to. Okay, so I'll see you then.